Let's have a better idea on how to sketch a sine functions using example number 1, where we have the function fx equals to 2 sine bracket pi over 4 minus x. So the first thing we want to do is that we want to find the initial point based on the phase shift, where we take the bracket terms here equals to 0, and we have x equals to pi over 4, where the cycle here is begin at x equals to pi over 4. Next, we would like to determine the periods, where we have 2 pi divided by modulus m, where the modulus m is referred to modulus of the coefficient of x here. So as a result, we have 2 pi over modulus -1. The answer is 2 pi. So one cycle of the graph will complete in 2 pi. And next, we would like to find out the subinterval width by using pi over 4. And this subinterval width will be the x value that we want to use for reference in the table later. So in this case here, we will have 2 pi over 4, and I get the answer pi over 2, again, which is the common difference of the x value in our table that we're going to construct later. So in the table here, we're going to construct a table of one cycle only as reference, where I will begin the first x value here using the value from the phase shift, which is pi over 4. The next value, we will add on with the common difference that we have just now, the subinterval width, pi over 2. So we add on pi over 2, we add on pi over 2, we add on pi over 2, we add on pi over 2. Once we get this x value ready, now we use our calculator to find out what is the corresponding function value accordingly. So we have the first one 0, -2, 0, 2, and lastly 0. So with this table here now, we can start to construct the graph of one cycle for the sine functions here, and therefore I will begin with the x-axis here first, where I would like to plot in all the x value I have in the table here into the x-axis accordingly. And then next, I will insert the y-axis and also the reference value that I need according to the fx value here, which is the 0 and -2 and 2. 0 will be just refer to the x-axis. And now, next thing I'm going to do now is that according to the table, I'm going to plot in the point accordingly one by one. So for the first pair, pi over 4 and 0, I've done the plotting. The next pair, the third pair, the fourth, the fifth. So once the plotting is done, the next thing what we're going to do is that we're going to connect them according to the shape of sine functions. So therefore, this is what we have. And once the graph is done sketching, by that we should erase the plotting there to show that this is a sketching, not a plotting graph. So this is the complete one cycle graph for the function fx equals to 2 sine pi over 4 minus x. And this one cycle graph here is important as a foundation for us to answer the questions later by the time they give us a specific domain. For example, if let's say the question now asking for the domain for all real number for x, that means I want the coverage from infinity to infinity. What will it happens to be is that if let's say this is the size of the y axis that I have, the coverage will be referred to the part that I highlighted in green now. So in order to get the answer, what I need to do is that I need to extend my graph accordingly to this part that is shaded in green. So before that, maybe we can continue labeling the x-axis towards the right and toward the left. By towards the right, we have it plus pi over 2. So these are the result I have. For the left, we minus pi over 2. And with this as guideline, we continue the shape that we have here to extend our graph accordingly. And this is how I get the answer for the case that x is for all real number, or the x is from -infinity to infinity. Next, if let's say the domain now, I want to refer to the case that I have x in the interval of 0 to 2 pi, which is equivalent to 0 to 360 degrees. How we shall do? Again, we use the one cycle graph here as a foundations. Then next, let us see how far is the coverage that we need to have here. So we notice that the original graph that I have here for one cycle, it doesn't cover until 2 pi. So let me extend the x value here towards the right side until I can have 2 pi. So by right, the next value after 5 pi over 4, I will have it as 7 pi over 4. And how I get this answer 7 pi over 4? By adding the common difference that we find out just now for the subinterval width. Follow, I will have 9 pi over 4. And we find out 9 pi over 4 is already exceed 2 pi. And where is 2 pi? It shall be somewhere on the left on 9 pi over 4, somewhere on the right on 7 pi over 4. Or I should say somewhere in the middle of 7 pi over 4 and 9 pi over 4. And therefore, this is the location of 2 pi. And therefore, the coverage that I need now is the one that is illustrated in the part highlighted in green. And continue. We're going to extend the graph according to the regions that we need. And this is the answer that we shall have. So this is how we get the answer if let's say they're asking for 0 until 2 pi.